Welcome class. This video is a continuation of our topic in metamorphism. Here we will focus in the types of metamorphic rocks and the metamorphic facies. There are two main types of metamorphic rocks. It could be foliated or non-foliated. Foliation technically refers to parallel alignment of minerals present in a rock. So technically, foliation is present in a foliated metamorphic rock and there is no foliation present in a non-foliated metamorphic rock. Now, as you can see here in this example, um, striping of minerals or alignment of minerals is present. So it looks like this rock has stripes on it, but technically these are aligned minerals. They tend to behave that way because this rock was exposed to certain type of conditions. Now, a non-foliated rock may not be may look this way because it is exposed to a different type of condition, which we will discuss later on. Now, metamorphic rocks, example of foliated, it could be a slate, phyllite, schist, and gneiss. And a non-foliated examples are amphibolite, hornfels, quartzite, and marble. Metamorphic rock is described as a rock that has planar foliation caused by the preferred orientation or technically the alignment of minerals. And this type of rock could be present if there is a significant amount of sheet silicate present in a rock. The composition of this silicate tends to behave in a way that it is long and flat like a sheet of paper, like you can see here in this picture. And another condition that could cause foliation in a rock is its exposure to differential stress, meaning to say the rock is exposed to unbalanced pressure coming from different sides, and this will cause the alignment of minerals. These are some of the famous examples of foliated metamorphic rocks. First one is slate. Because of foliation, slate breaks into thin or very thin platy layers like what you can see here in this picture. This is described as having a slaty cleavage. In a way, after exposure to pressure, silicates align themselves, forming a rock we refer to as slate. And if you look closer or microscopically into a sheet of slate, you can see that there is an alignment of minerals or silicates in this rock. Next example is schist. The striking feature of a schist is the presence of irregular planar foliation, or as you can see here in this picture, this foliation. So this happens when a slate undergo continuous metamorphism. So since it continued to undergo or to be exposed to increasing heat and pressure, its minerals will crystallize bigger, making the foliation more obvious. And at the same time, the increasing pressure will cause the irregular alignment of minerals, like as you can see here in this diagram. So there is no straight alignment of minerals but somehow irregular, and this is referred to as schistosity. As an example of foliated metamorphic rock that we have is a gneiss. So the striking feature of a gneiss is the presence of a gneissic banding. Now, this gneissic banding is described as the foliation of dark colored minerals, as you can see here in this example. Let's go with non-foliated metamorphic rock. So as the name implies, this is the type of a metamorphic rock that does not have foliation or it lacks a planar fabric alignment of minerals. This happened because the rock is not subjected to differential stress, meaning there is just a confining stress. Equal, there is an equal pressure coming from all directions that is where the rock is exposed to. Next, the dominance of equant minerals, meaning these are the minerals that tend to crystallize like a cube. So there is no minerals that tend to behave like a long and flat surface because there is an absence of platy minerals. Now, examples of this are amphibolite, hornfels, quartzite, and marble. Let's let's take a closer look at the appearance of non-foliated metamorphic rocks. In here we have marble, amphibolite, and quartzite. So as you can see here, there is no foliation obvious in each type of rock or in each example. The last concept that we need to learn in this video is the metamorphic phases. Technically, metamorphic phases is defined as the groupings of rocks of various mineral compositions formed under different grades of metamorphism from different parent rocks. So this diagram shows the different metamorphic phases. You have zeolite, green schist, blue schist, amphibolite, granulite, eclogite, hornfels, and saninidite, and others. Now, they are grouped according to the temperature and pressure they are exposed to, and at the same time the composition that they have. A metamorphic phase will or the metamorphic phase will only help us understand the condition undergone by a certain metamorphic rock, which we will discuss deeper in the next slide. This diagram explains the condition faced by different phases. Look closer in line A. The condition in line A will lead to the formation of hornfels and granulite. This suggests that the rock is exposed to high temperature but low pressure. So in here, line A or the rocks in line A may only be exposed to around 300 MPa, but the temperature, as you can see, may increase up to 1000 degrees Celsius. Next, line B. So they suggest that the rock is exposed to high pressure and temperature. And zeolite, this is line B, zeolite may then metamorphose into green schist, amphibolite, and granulite. So as you can see here, temperature is increasing. It reaches until 600 degrees Celsius, and at the same time, the pressure may also be at extreme, which is 1200 MPa. Last is line C. With line C, you have high pressure but low temperature. So blue schist together with zeolite and eclogite will form in here. And that's the end of this lesson. Thank you.